Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to be an introductory video on solving second order homogeneous differential equations. So first let me have a little discussion about differential equation theory in general. You know, differential equations come in all types and forms. The two we're looking at here, because this is a second derivative in here and here, both of these are called second order differential equations. Now, some differential equations are first order and can be solved by separation of variables, but second order cannot. And third order, fourth order, fifth order, all those can't be solved that way either. So, you know, the million-dollar question, well, how are they solved? There are just a plethora of different methods for solving differential equations, but the overwhelming majority of them have one thing in common. You start with what's called, or what I like to call, a guess function, some sort of guess as to what the solution looks like. For now, I'm even going to call it like y sub g here, the g standing for guess. And you can get a guess as to what type of function will solve it via a couple ways. One, if it's a physical problem, you could look at the actual physics of the problem or the chemistry or the math of it or what you will, and that'll sometimes give you a clue as to what type of function will solve it. The other way is to study the equation itself. So let's take a look at this. We're going to take a look at this one here. D squared y dx squared minus 4y equals 0. So the dependent variable here is y, and the independent variable is x. And the solution to this is some function. Y is a function of x. And this equation is saying that, you know, whatever y is, you can differentiate it twice, subtract it from itself to within a multiple of 4, and get 0. So there's only one type of function in all the universe that exhibits that type of behavior, and that's the exponential function. This function could be something like, maybe, you know, like y equals e to the x, or maybe e to the 2x, or maybe e to the 5x. We don't really know the power yet, so in general we're just going to say y equals e to some constant times x. Now, furthermore, there may be some sort of constant in front of it here, so maybe I'll put an a here to represent the constant. So you take a guess at what your function is going to look like, and here's my guess for the solution of this animal. Then what you do is you take your guess solution and you dump it into the differential equation and see what you get. And first, you look to see if it works, and second, if it does, you see if you can nail down some of the constants that are within your guess function. So in order to sub this in, what I'm going to need is this thing's second derivative. So I'm going to go ahead and calculate a first derivative, which is going to be ac e to the cx. Remember, the derivative of e to the u is e to the u du. Differentiating this again, we're going to get ac squared e to the cx. And now we're ready to go ahead and take this and sub it into the equation we're trying to solve. So if we do so, and I'll pick up right here, we're going to read what ac squared e to the cx minus 4y, and a y we think can be written a e to the cx, and then equals 0. Now, you'll notice that we can factor some stuff out here. We can factor an e to the cx out. We can factor that a out. And what we're left with here is c squared minus 4 equals 0. Now, it looks like this equation is working. In fact, it is. Let's go through some possibilities here now. We've got the product of three things equaling 0. Well, the first one here, can a equal 0? Well, if it did, look back at our original. Our original function would be y equals 0. And that does, in fact, solve this equation. Second derivative of 0 is still 0. Minus 4 times 0 is equal to 0. But that's called the trivial solution, not what we're looking for. E to the cx cannot equal 0. There's no value of x that's going to make that a 0. So we're left with this one. Now, if we solve this, we get c squared equals 4, and c could be plus or minus 2. So we found two different values for c that will solve this. So one possible solution, and I'm going to call that y1, is y equals a, which is just some constant, e to the 2x. But an entirely different solution is y equals maybe some other constant. I'm going to go ahead and put b e to the minus 2x, because these two different values for c, plus 2 and minus 2, give us two different types of functions here. You know, y equals a constant times x, and y equals minus a constant times x. Now, you know, again, this is just meant to be an introductory video, but it is a fact of differential equation theory. Equations that are linear in nature, and these things are equations where if I have two different solutions, the sum of the two is also a solution. That's called your general solution here. So the general solution of this equation is y equals a e to the 2x plus b e to the minus 2x, where the a and b are just constants that you would determine with more detail. There's not enough information here to solve for a and b. The way they would be solved for, however, is maybe we had some conditions on this, like maybe somebody said, oh, at y equals, or when x equals 1, y is equal to 3 or something like that. And what that'll do is allow you to write an equation here. And then typically you get a condition on the derivative, like maybe y prime of 2 is equal to negative 5 or something like that. And that would allow you then to calculate this thing's derivative, write another equation for a and b. I'm not going to do that in this video. This is just meant to be an introductory video, so I'm just going to leave it at that. Let's take a look at this one now. So this equation is pretty similar. I'm going to take this stuff and shrink it down and move it over, maybe a little bigger so the viewer can kind of look back if needed. So we're going to take a look at this one, and again we want to think to ourselves, what type of function is going to solve this thing? What is this going to look like? Well, whatever y is, this is saying that you can hit it with two derivatives, add it to itself, to within a multiple anyway, and get 0. The types of functions that exhibit that behavior are sines and cosines. Now, a sine function can be differentiated twice. So one possible solution for this might look something like y equals a sine of maybe bx. I'm going to call that one y1. Another possible solution, well, a cosine function also exhibits this behavior. Differentiate cosine, you get minus sine. Differentiate that again, you get minus cosine. So that could be some other constant. Cosine of, for now I'll say dx. Now I'm going to go ahead and take one of these and wash it through this. And in order to do so, we're going to need a second derivative. So let's start with the first derivative. Differentiating this function, we get a b cosine bx. Hitting it with another derivative. And again, the derivative of cosine is minus sine, so now we're going to have minus ab squared sine of bx. And now what we can do is take this and sub it into our original equation, minus ab squared sine of bx plus 4 times y, which we believe looks like a sine of bx equals 0. Do a bunch of factoring. Let's see, we can factor an a out, a sine of bx, and then we'd be left with minus b squared plus 4 equals 0. Now, we take a look at this thing, we say to ourselves, can a equal 0? And the answer is no, because we would have killed off one of our, we would be down to the trivial solution. Sine of bx is not always equal to 0. It can be at specific values of x, but it's not always. Then the other solution here, b could be plus or minus 2. Now, I know it looks like perhaps that's yielding two different solutions, but it's pretty easy to show that this still corresponds to one solution, because if I put that 2 in, this is going to read y equals a sine of 2x. If I put a minus sign here, like if I compare this to a different equation, let me call it a prime sine of minus 2x. The sine, remember, is an odd function. This is equal to minus a prime sine of 2x. And I could let a prime equal minus a, and you're back to exactly the same solution. So this does not actually yield a second solution. Same thing if you put a minus sign with a cosine function. The cosine's even. Cosine of 2x, cosine of minus 2x are identically the same. So what we have here, here's our solution of this equation. Had I subbed this one in, and you follow it through, I'll leave this as an exercise to the reader, what we would have ended up with is d equals 2. So we would have had our y2 would have came out to be, whoops, c cosine of 2x. And you notice this value ended up the same. They're not exactly the same functions, one's a sine and one's a cosine, but the number in front of the x here would have ended up the same either way. And our general solution of this equation is the sum of the two, a sine of 2x plus some constant c cosine of 2x. So that's just a little bit, just a little taste, I guess, of solving second order homogeneous differential equations. Again, the idea is you typically start with some sort of guess as to what that function looks like. You then plug it into whatever equation you're dealing with. Now, when you actually take a differential equations class, you'll talk about many, many, many different ways that these guesses can look. After you plug it in, you see if the thing works, and you look for appropriate constants. Now I'm going to make another video about finding the other constants, like what do we do with these guys, like the a and the c, and over here the a and the b. And again, these a's, b's, c's are just numbers or just letters I'm assigning to represent constants in these problems. And again, I'll make a separate video on finding those. So I hope that this video at least helps give you a basic understanding of how these things can be solved. Have a great day.